Now we will be solving the second session 2018 for grade 12 LS. Okay, and as usual, we have a capacitor that is initially on charge. So at the beginning of the experiment, UC was simply 0 volts. We have the capacitance, we have a resistor of adjustable resistance, an ideal battery E, and the switch. Now, we have the first part theoretical study, derive the differential equation that describes the variation of the voltage. And I think this is really easy by now. If you find it hard, you can go back to the previous videos. I solved that like around 4 times. So this will be very easy if you watch the previous videos and you decompose the question to steps as I just did. Okay, so to find a differential equation for UC, we start the first step by law of addition of voltages. Okay, and then we say the battery is giving out to the capacitor and the resistor, and simply we can state that Q of the battery is E minus Ri, and since we don't have internal resistance, so simply UB is E. However, the voltage of the resistor, it's Ri. Okay, so simply we replace each one of them by its own formula. UC, we keep it because we want UC. Now, my only problem here in the second step is that I have two variables, which is UC and I, so I should be replaced by something concerning UC. Why? Because they want the differential equation for UC. So the only formula that I know for I is dq over dt. And simply, U has its own formula, so I will replace Q by its formula, which is CUC. And since C it's a constant, we keep it outside of the derivative, so we will have C outside, then derivative of just UC. So simply R is replaced by C duc over dt. Okay? I will be replaced by its formula C duc over dt. So E equals UC plus R. And instead of I, we will put C duc over dt. Now, the last step, it's something preferably we can do it unless they want a specific form of the differential equation. Divide the whole thing by RC. You will get E over RC equals UC over RC plus simply the derivative of UC in function of time. Both of them are differential equations, by the way. Okay, it's your choice if you continue till the end, so you can keep the derivative by itself without a coefficient, or you can stop here unless they force you to find a specific form for the differential equation. And I think that's really easy by now. Now, the solution for this differential equation has the form A plus B, E dt. Determine the constants A, B, D in terms of E, R, and C. I have to write the differential equation in front of me, the solution in front of me, which is UC is A plus B, E, D, C. And I write the form that I know from the course, which is E minus E minus T over tau. Why am I doing that? So I can know what are these coefficients supposed to be. Okay, what these coefficients are supposed to be. Okay, so by comparing, I can see that A should be E, and B should be minus E, and T is simply T, and D should be minus over tau. So I will keep them on my mind so the calculation can get me through to the correct value. So A should be E, B should be minus E, and D should be minus 1 over tau. I should get that in my expressions. When I say minus 1 over tau, I mean minus 1 over RC. Okay? So let's consider that this is a scratch, and I will try to solve as I usually do. What do I usually do? I decompose these questions into 5 steps or 4 steps. I write the solution in front of me. I'm sorry, without the minus, it's simply dt. Okay, I find the derivative. This is my first step. The derivative of a constant is 0 plus b e dt. And I will simply put in between what's next to the time, which is d. D is next to the time. So the derivative is d e dt. Now, since I got the derivative, and I have the solution from the given. These are expressions 1 and 2, let's say. We have to replace 1 and 2, replace them, replace in the differential equation. And what is my differential equation again? E equals UC plus RC duc over dt. Okay, so UC should be replaced by 1 and duc over dt by 2. What do we get? E equals UC, it will be replaced by its value, which is A plus B e dt, plus RC, it will be kept. DUC over dt is what should be replaced, and it should be replaced by its value, which is B dE dt. We remove the parentheses. The first parentheses, there's nothing to expand, so we simply just rewrite what we have. Plus RC is multiplied by this expression, so RC B D E dt, the whole thing. Now, the third step, we take exponential as a common factor. So E dt is a common factor. For which expressions? This one has an exponential and also this one. So everything next to the exponential will be written in the parentheses. So B plus RCB, and that's it. Now we compare the constants. So E should be equal to A, and this is what I expected at the beginning. Okay, now the second part, the exponential can never be 0. So what must be 0 is the factors of the exponentials. Okay, so we put each one of these expressions on a side, B minus RCBD. And since I have B and B on both sides, we can remove them. So we will end up with 1 equals minus RCD. Okay, so what is D supposed to be? We will take minus RC to the other side, and we're not changing the sign of minus here. RC is multiplied by D, so the multiplication will be division, and the sign will simply be kept. So minus RC. Okay, and as I expected at the beginning, it should be D should be minus 1 over tau. Minus 1 over tau, which is minus 1 over RC, and this is exactly what I got. This is not a familiar expression to have, but once you compare them at the beginning on your scratch, you can make sure that everything you have is correct. Now I got D, great, and I got A, also great. The only one that is missing is B. So I will rewrite the expression, and if it's really hard for you, you can go back to the previous the previous video. I solved something similar to that. Okay, so UC is equal to A plus B E dt. Now replace them. What you know now, we know that A is E, B we don't know it. D, we will write T. T is kept. Okay, D, instead of D we will put a minus and over RC. Okay, the only thing that is missing is B. And as I said before, every time you try to find a missing coefficient and there's nothing else to solve in the equations that you were trying to do here, you use the initial condition. What does initial condition mean? Initial condition, use the values that you have when the time was 0. When the time was 0, everything I knew that UC equals to 0 volts. 0 volts, okay? So I will use that in my expression for UC, and I will see where it gets me. And this will get me to replace the time by 0. Okay, and exponential of 0 obviously is 1. And it will get me to replace UC by 0 because at the beginning of the charge phase, as I said in the previous video, that at the beginning of the charge phase, UC is 0. However, at the beginning of the discharge phase, UC should be E. Okay, so 0 equals E plus B times 1, it's simply B. And B then should be minus E, and this is also what I expected, so it's correct. Okay, so the initial conditions in physics, they really can save you. Now, verify that the capacitor becomes a practically free charge at T equals 5 RC. Now, as I said before, the questions are obviously connected to each other. You have to think in steps. Okay, so they're telling you prove that when the time is replaced by 5 RC, then the capacitor should be fully charged. They're giving us a hint about the time. And they just asked us in the previous question about the solution. Let's benefit from that. You see it's equal to E minus E minus T over RC. So I replaced A, B, and D. Now they're telling us that the time, in this case, it's 5 RC. Okay, let's do that. You see when the time is 5 RC, is E minus E minus 5 RC over RC. So instead of the time, we will simply just put 5 RC. RC and RC, obviously they have to be removed. And UC equals E minus E minus 5. And if you solve that, if you get the value of E minus 5, E minus 5, it should be something very small, like 0.006, I think. Okay, and when you multiply something very small by E, you will get a very small number. Okay, if I want to make this clearer, if I take E as a common factor, I will have 1 minus E minus 5. Okay, this expression here is very close to 0.99 something. Okay, 0.99 something, it's very close to 1. So it looks like, you see, it's approximately equals to E. Okay, and when UC has the voltage of the battery, that means it took everything from the battery and it's fully charged. Okay, and when UC equals to E, so it's completely charged. Now, indicate the effect of the resistance of the resistor on the duration. What is the effect of the resistance on the duration? The only thing that relates the resistance to the duration is what I know about tau. Tau is equal to RC. This is the only expression that relates the time to the capacitance or the resistance. Okay, now what is the effect of the resistance? The effect is if we increase the resistance, then the time to charge the capacitor will increase because tau is the time. Time of what? Time to charge the capacitor. Time to charge the capacitor for about 63% of its maximum value. So if R increases, then tau increases, then the time to charge the capacitor increases. As simple as that, and vice versa. If R decreases, tau decreases. And by the way, this question is not only about the resistance. This could be asked about the capacitance. What is the effect of C on the time, on the duration? It's the same thing. Instead of R, we just say C. Okay. Now, this is the first part. The second part, we have two graphs, and it's an experimental study. We have two different resistors. We have two different, I mean, the same resistor, but two different values of resistances. Like we're using a rheostat or something. Okay, we have curve A for resistance 1 and curve B for resistor 2. Okay, now let us think about the graph for a little bit. The maximum value that I have here is 8. Okay, find 63% of this value. 63% of 8 is approximately 5. 5 is somewhere here. So tau for the first graph is here, but tau for the second graph is here. Okay, so you project the number 5, the voltage 5 on both curves, you will get a point here and a point here on both curves. If you project on the time axis, you will see that the first curve has 0.4 millisecond, however, the second has 0.8. What does that mean? The tau for the curve A is smaller. So curve A takes less time to charge. The capacitor in curve A takes less time. So tau is smaller. I cannot not read the graph like this before reading any question. Okay, so when something appears to be more curvilinear, or some people say it in other terms where they say the curve A reaches the maximum state, which is 8, long before curve B. Curve B approximately reaches the maximum point here. However, curve A reaches the maximum value, which is 8 here, way before curve B. So it's charging for it to be completely charged, it's taking less time. So you have different ways of approaching things, okay? Now, 2.1.1, specify the value of E, since both of them, both of them have an horizontal asymptote, which is UC equals to 8, then simply UC is equal to 8. UC at the steady state is 8, but E is 8 because 8 is the maximum value that the curve can attain. Okay, so 2.1.1, E it's equal to 8, justify because 8 is the maximum value that both curves can attain. Or you can simply say it's the horizontal asymptote. The curve gets really close to 8. Now, 2.1.2, specify without calculation whether the value of R2 is equal, greater than, less than the value of R1. And this is really a good question. This is what we talked about. Curve A, it's taking less time. And if we have less time, then we have less resistance. Okay, so in 2.1.2, we have to say tau 1 is smaller than tau 2. And since tau is highly dependent on R and C, but see, in my problem here, I'm not changing the capacitor. So see, it's staying constant. What's affecting the time here is the resistance. Okay, and since tau 1 is smaller than tau 2, then simply R1 is smaller than R2. Okay, how did you know that tau 1 is smaller than tau 2? You have to explain that. You have to say that UC is equal to 63% or 0.6 times 8, which is approximately 5. Okay, for curve A, tau 1 is 0.4 milliseconds. However, curve B for the same exact voltage is 0.8 milliseconds, so it's taking more time. Okay? Or what can you say? As I said, method 2, we can simply say that curve A reaches the steady phase before curve B. So معناتها, what does that mean? So the time for curve A, or the time for the capacitor to be completely charged with resistance R1, it's taking less time. But also we can say tau 1 is smaller than tau 2, or T1 smaller than T2, or 5 tau tau 1 smaller than 5 tau 2. And you can repeat the same. R1 is smaller than R2. Now, determine the value of R1 and R2. Now, they're asking us about tau in the previous question. They didn't ask about tau. They asked about if R1 is greater or smaller or equal to R2. And we immediately related that to tau. Okay, so if we want to get the value of R1 and R2, let's also relate that to tau. Using the graph, I just mentioned that tau 1 is 0.4 milliseconds. Tau 2 is 0.8 milliseconds. So I know tau. Okay, and I know C in this exercise. It's mentioned in the given here. It's 4 microfarad. Okay, so I have C. And I have, I'm sorry, I forgot the value, 4 microfarad, yes. 4 microfarad, which is 4 times 10 power minus 6 farad. And since I know C, and it's the same for both curves because I'm not changing the capacitor, I'm just changing the resistance. Simply we say tau 1 equals CR1, and tau 2 is equal to CR2. We're not saying C1 and C2 again because it's the same capacitor. So R1 is equal to tau 1 over C, and R2 is equal to tau 2 over C. Tau 1 is 0.4 milliseconds, so we converted times 10 to the power minus 3 to convert it to seconds, over C, which is 4 times 10 power minus 6. This is R1. What about R2? R2 is tau 2, which is 0.8, and we convert this to seconds, over C, which is 4 times 10 power minus 6. So what do we get? R1, it's equal 4, we cancel them, 10 to the power minus 4, 10 to the power 2 ohm. Here we have R2, it's equal to, we remove that, we will get 0.2, which is 2 times 10 power 2 ohm. Obviously, R1 is smaller than R2. Okay, 100 is smaller than 200. Now, the capacitor is fully charged. The electrical energy stored in the capacitor is WC. Is the value WC affected by the resistance? When they ask you if things affect each other, you have to think in terms of the formulas. What do I mean by that? What is the formula for the stored energy in a capacitor WC? It's half CUC squared, okay? Or it's half Q UC, or it's half, we replace Q by CUC squared, or we can see by CUC, or we can replace UC by Q over C. So we will get Q squared over C. So those three expressions are valid. Okay, none of them is related to the resistance. Okay, so no, the resistance doesn't really affect the stored energy, because at the end, when the capacitor reaches its steady state and it's completely charged, this is affected by how capable the capacitor is to accumulate charges, which is C, the capacitance, and it is related to the voltage of the capacitor. Does it have a big voltage, a small voltage? The voltage also decides how much a capacitor can handle charges. Okay, so deduce the value of WC. WC it's equal to half CUC squared. At the steady state, when it is completely charged, meaning when the time is bigger than 5 tau, UC takes the voltage of the battery, which is E. So simply, instead of UC, we can put E squared. And in this exercise, we have half C, we have E. Oh, we don't have E. Okay. Didn't I include that somewhere? Oh, yeah. Yes, we got that. In 2.1.1, or from the graph. E is equal to A. Okay, I got that. So C, it's 4 microfarad, so 10 to the power minus 6 to keep it in farad. And E is 8 squared. So what do we get? 2 times 10 power minus 6 times 64, which is 128 times 10 power minus. You can do this with a calculator. I don't have one now. So WC is simply 0.128 milli joule. Okay, or you can simply just say 128 times 10 power minus 6 joule, or whatever you get on your calculator. So this is the session. I think everything is so easy by now and repetitive for this chapter. If you watch all the videos, you can see how easy it is when you decompose things into steps. I have the time to continue with this chapter because I have to focus on other chapters too, so I can be fair. Okay. If you find this beneficial, share it, subscribe, like, comment your questions. This would really help a lot. And thanks for the support in advance. See you next time.